Hello everyone. In this video, I'm going to talk about decision making under uncertainty, where we're going to examine the difference between zero tillage and filter strip for reducing erosion. In that Z-score program, we compared two scenarios at the time of measurements using a calibrated model. So here you needed to have an observation file where we looked at the significance of differences between two scenarios at the time of measurements. As you recall, this first column is the column of time in the observed file. But in Z-score no observation, we don't need to have any observations. So you can compare the differences of two scenarios at all time steps during the simulation time. So here you don't even need to have a calibrated model. The program is ideal for management decisions between two alternatives where you don't have to have a calibrated model. I'm often asked, I don't have any observations. Can I still use my SWOT model? I think you can use the SWOT model if you are interested in relative changes between different alternatives and you don't want absolute values. Say you don't want to know how many tons of erosion you have. You want to know if you have less tons of erosion between alternative one and alternative two. So the example that I'm giving today is about soil erosion control. And what the question is there a significant difference between zero tillage and filter strip to control soil erosion? And initially, the farmer is practicing subsoiling for tillage and wants to know the change that would take place if he changed his practice. So what would be the difference between zero tillage and filter strip if he wants to control soil erosion? So we want to know if there is a significant difference between these two methods that, of course, cost differently. So we would like to know which one is better to control the erosion or if there is any difference between them. So the steps that you have to take to answer that question is, first of all, you build a SWOT model for the watershed. And to build the SWOT model, as you know, you need soil map, land use map, climate data, and management data. So you don't have to have any observations here. Soil map, land use map, and climate data are now readily available from many places. And management data, of course, is known by the farmer. So with these four information, you can build a SWOT model. In step two, you select some relevant parameter ranges from the literature. For example, for flow, these are the usual important parameters. So these are the ranges that you can initially use. For sediment, for nitrate, for total phosphorus, the same thing. You can use these parameters and these ranges. So if you want to look at something related to flow, of course, you need the flow parameters. If you want to look at sediment, you need flow parameters plus sediment parameters. If you want to know nitrate, you need flow parameters and nitrate parameters. And if you need to know about total phosphorus, you need to use flow, sediment, and total phosphorus parameters because phosphorus moves with sediment. So these are the parameter ranges, typical parameter ranges and parameters that you can use in your model. Step three is do an iteration with the base model. Our base model in this example is a model where the farmer practices subsoiling, which is one of the worst possible tillage practices there are. But we want to compare, so he's using subsoiling and wants to know if he can implement zero tillage or filter strip. So you do an iteration here with the parameter ranges that I showed before, and you save this as iteration one. That would be your base model iteration. In step four, you do an iteration with alternative one, which would be zero tillage. You do an iteration and you save as iteration two. In step five, you do an iteration with alternative 2, which is filter strip. Again, you save it as iteration number 3. And then you run the Z-score no observation for iteration 1 and iteration 2 in the status quo, which would be subsoiling practice and zero till. And then you do the same thing. You run this program for status quo and filter strip. You call them iteration 1 and iteration 2. That's the program looks for iteration 1 and iteration 2. And then in the next run, you do an iteration with exactly the same parameters, right? You don't need to change the parameters. It's not a calibration procedure here. It's just comparing the differences. So you run with filter strip and zero till to see if there is a difference between them. With these runs, you can do a lot of analysis. I will talk about some of them. Now, BMPs in SWAT programs, there are several different options for BMPs. In SWAT-Cup, I sort of addressed this, but I never got a chance so far to really complete this step. If you press import files, go to utility program and import files, you will get a folder called utility program in your SWAT-Cup project. If you go in the utility program, you will see different BMPs, conservation tillage, contour farming, filter strip, and so on. Now, I prepared these files, and if you look at the different files, for example, conservation tillage, you get a small explanation of what it is. You get a paragraph about the end result of conservation tillage. What would that be? And then you get the design parameters that you need to address for conservation tillage. Zero till would be here. So if you put this to 25 millimeter, you will be simulating zero tillage. And the CN2 should have a range between minus 0.1 and 0. And then there is an explanation and literature and references. So all of these have one page that explains to you very simply filter strip, what it does, what is the end result, and what are the design parameters. So for filter strip, you need to adjust this filter width in the management file. You need to give that a value. And then you have two parameters that they appear in the operation files of SWAT, and these are the ranges. So with these parameters, you can simulate filter strip. In fact, you can use SWAT-Cup in a situation like this to design filter strip. So you can run an iteration with a range of values for filter strip, and then for different, run 100 simulations. For each simulation, you summarize the sediment load, and then you'll see which sediment load fits your criteria. So for that, you can use that filter strip width. So you can design these using SWAT-Cup. I was planning to do a DSS, a decision support system. That's why I put the BMP in SWAT-Cup, but I didn't have time to complete that. But you can see that you can design various management practices, and you can in your objective function you can add an element of the expenses, the dollar value of implementing different projects, and you can optimize that objective functions so you can really design the practice that you would like to implement and see the effect of it. This I didn't get to do yet, but I'm planning to do this. And probably maybe by the end of this year. Since I mentioned this, I would like to say that there are some people who are trying to copy SWAT-Cup. They try to write the program in different languages, in Python, in R, and so on. And my message to these guys is that, look, why are you trying to copy something which already exists? You can do much more useful stuff. You can deepen the analysis. I mean, you can do a lot of analysis after you calibrate your model, but we usually calibrate the model and leave it there. You can do a lot of analysis and you can write a lot of programs that can do different analysis. So don't waste your time copying something which already exists, half as good as what it is. And there is no point in that. Use your time to develop something new, to add something to the analysis and take it forward. Don't go backward. Anyhow, you have contour farming, you have for all of these BMPs, a certain design parameters that you can design it. So if you want to do a contour farming, you can actually design the important parameters and so on, the terracing and so on. Now, this in the operations, these are in the operation files of SWAT. So if you go to subbasin, edit subbasin inputs, at the end you have operations. So if you go in that operations, you will see different BMPs that you can implement, and you just fill the information and uh, write the text files, and there you have that specific BMP, which is what I did for zero till and for filter strip. Now, once you have this, the only thing is that I should mention is that these parameters I use flow and sediment parameters with these ranges. These ranges stay the same. Each time I do a iteration, I use 64 simulations with these 10 parameters for each case. And then the only thing, because it's a no observation case, the SWAT-Cup files that you need to edit is the extract, SPE extract.bat or SUFI2 extract.bat. And here, the only thing that you want to extract is no observed reach. And then you need to edit, extract no observed reach definition file. And here you have name of the program, name of the SWAT output file, the number of variables that you want, column number of the variable, and name of the variable. I use R sediment because you can extract sediment from different output files. So R means reach, means from reach sediment. And then the total number of subbasins in the project, I have 54 subbasins. This project that I ran is a small watershed in Danube Basin. And the number of subbasins to get the variable from is all. I want to extract all of the 54 subbasins and see spatially where the difference is between the two different practices. And then the year is from 1973 to 2006, about 34 years. And I ran the program yearly and monthly. So here would be a yearly run. And then the other file that you need to edit is SPE no observed post processing.bat. And here you would like to remark everything. This means the program doesn't execute this. So in this batch file, you only want to do the 95 PPU of this program. So these are all remarked. I have made 3 text in outs, right? This is text in out for zero tillage after I implemented it in SWAT, an arc SWAT. This is text in out for filter strip and text in out for the initial model, the subsoiling, where the farmer is practicing subsoiling. And then each time I copied text in out into my base model. My base model was this one, the subsoiling was the base model. And then I built the text in out and copied it here. So this is 3 SWAT-Cup projects. So if I go to any one of these, let's say the initial model, in the initial model, I made an iteration and saved the files here. I did monthly iteration, right? And I did yearly iteration. So this would be the subsoiling. Of course, the Zscore doesn't use all of this information, but it doesn't matter. You just can copy the whole iteration here. And then the same thing for filter strip. After I copied all the text in out here, I did also an iteration with the same parameters. I did monthly and yearly iteration. And then you go to the zero tillage, the same thing. I did just one iteration and I copied the iteration here. After that, then I went to the test folder here. So first I have the subsoiling. The subsoiling, this is the subsoiling filter. This is the subsoiling with zero till, and this is zero till with filter strip. So I compared all of these. So in subsoiling zero till, I did monthly and yearly. So if I go to monthly, iteration 1 is the case for subsoiling, the status quo. Iteration 2 is for zero till. And then you run the program. When you run the program, you get these 1, 2, 3, 4, 5 files, not the Excel file yet. You get these 5 files. The first file is an echo as usual. The program just echoes what it reads, so you can see if everything is being read okay. I have 10 parameters, I have 64 simulations and 54 variables. These are the 54 subbasins. And then I get these two files, Zscore from iteration 1 and Zscore from iteration 2. If I go to iteration 1, I have, this is this for the subbasin 1. This is variable 1. This is the time. So the time is for 34 years, I have 408. That would be 408 months, right? So these are 408 time simulations. And then what you get is for every time step and for that subbasin, you get the average of sediment and you get the variance of the sediment. So the uncertainty, right? And then you get to iteration 2. This would be the case for zero. So I can put them together next to each other so you can already see the difference that zero till would make. So this is again variable. This is again subbasin 1, variable 1, and time 1. So the average for that month, the average sediment yield is 659 here with zero till, and it was 1,535 for subsoiling for the status quo. SWAT is quite sensitive to subsoiling when it comes to sediment. And then these are the variances. So the question, therefore, what we have is that, is there a significant difference between this and this given the variance? So that's where we calculate the Z-score, right, to answer that question. And then, so the same thing, after this, you get a file called Z-score. In the Z-score, you compare these two, and you get actually the actual Z-score appears here. So again, the subbasin number 1, that's variable 1, and this is the times, the first month. So I explained this in the last video. If Z-score is less than 2, the difference is not significant. If the difference is between 2 and 2.5, the difference is marginally significant. Between 2.5 and 3, it is significant, and more than 3, it is highly significant. So, and anything above 3.5, I set it equal to 4 in the program, so we can see it better. So this would be highly significant, and this would not be significant. So the first month is significant, the second month is not significant, the third month, the fourth month, the fifth month, the sixth month is not significant, and then the 7, 8, 9, this would be the summer months is highly significant. So you can see when and where. This is where and this is when it is significant. This would be when here would be significant. So you get this for every subbasin or every variable. Here our variables are just different subbasins. And then at the end, after 408 80 months. That's their simulation period. You get a little summary here. You'll get a little summary here. It says 33% of times the difference was significant, was highly significant. And then 8% of times it was significant. And it was 7% of time it was marginally significant. And then, therefore, 52% of times it was not significant. So the difference was not significant for subbasin number one. Then you can have the same thing for subbasin number two, subbasin number three, and so on and so forth. So it will tell you that spatially and temporally what is the difference significant. So you can do a lot of analysis here to see why, what time, where is the location of the subbasin, why is it not significant, or why is it significant, what is the soil, the relation with the soil, with the land use, with the climate, and also you can analyze, you can see, you can make the correlation to why is it significant, why is it not. Maybe the significance appears only in the rainy season, so you should get a pattern of significance and non-significance. Now, there is another file called the summary significant where I summarize the significance for each one here. And here you can see that for these are our subbasins, 54 subbasins. There are 54 variables. So for the first subbasin, highly significant 33%, only significant 8%, and marginally significant 7%. So not significant was 52%. So 52% of times the difference was not significant. So next, is this Excel file that plots the Z scores. In this file, I can just copy it exactly as it is and brought it into Excel. And I can plot it here. I will soon make a program that can make nice plots out of these. And the way I plot it is like this. I take the Z score, and then I plot it as points like this, right? And then I take these cutoff values. I use the cutoff values here and copy them. And then I paste it, just simply paste it here. And it'll give me these graphs. So here you can see visually that this would be the not significant here below 2. Between 2 and 2.5, this would be marginally significant. Between 2.5 and 3, that would be significant. And above 3, all of these would be highly significant. So you can see almost half is not significant, as half of the time it is significant. So it would be nice to do some analysis to see when is it significant and when it is not significant, because we have time here and we have the space. And here would be for subbasin number 2. So how does the subbasin number 2 behave? So you can do, again, some analysis here. So let me go on. I will show you. Now, this was subsoiling and zero till, the same subsoiling and filter, but we were mostly interested in the difference between zero till and filter. Again, here is monthly and yearly. So let me just go to yearly. I have 2 iterations. Iteration 1 is zero till. Iteration 2 is subsoiling. Again, I can look at these statistics. Okay, this one. All right, so here you can see also the difference. So this average, this is annual run. This is for filter strip, and this is for zero till. So you can see filter strip is less than zero till, right, in this example. So you can do some analysis here with these numbers, but then the next file would be Z score. So Z score tells me for sub-basin number one, and here different observations. Here I only have 34 years. So you can see that it is not significant here. It's marginally significant here, is highly significant here, highly significant here, and so on. So this one you can also plot. I already plotted it in. You can look at the summary significance like before, and this summary significance is telling you 18% of the time is not significant, 97% of the time is not significant, and so on. And then you can again plot this for temporal difference. So here I plotted it. So here you see we have like 34 variables because 34 we have 34 years, 34 years for sub-basin number one. So you can see that here. So it's mostly significant. It's highly significant here in these areas, uh, and only a few cases which is not significant. So for sub-basin number one, it would be significant, and you can plot similarly for sub-basin number two is not significant, and this has a nice pattern that can be analyzed. Play with, and here is the third one, the third sub-basin. Again, this sub-basin is highly significant. All of the points are significant. And again, a nice pattern here that one can analyze. It's probably the time of the year and so on. Now I can go back to my ArcSWAT project, and if I highlight the subbasins that are significant, that were highly significant, I find these. So the subbasins in the northern part and this one here, these were highly significant. So that means there is some kind of relationship probably with the land use or soil or climate that one can deepen the analysis by looking into these things. As I said before, I'm going to make this DSS, and I invite you to also try to do these kind of things. Useful analysis. It's the analysis which is important, really, after you calibrate your model. So there are a lot of things that can be done after model calibration. So don't try to copy just what already exists. Try to write some programs that people can use to analyze the situation, to deepen their understanding of the situation, the importance of soil, the importance of land use or climate or management, and so on. Also, these programs are not yet available. I'm going to put them soon. As soon as I have the graphics program, I will put them soon into our website, so you can download it from there. The program works right now it works for SWAT-Cup Premium and SWAT Plus Cup. It doesn't work so far for SWAT-Cup 2019. I'm trying to not do too much more with SWAT-Cup 2019. I encourage you to switch to SWAT-Cup Premium, and I will not be doing too much development with SWAT-Cup 2019. I find SWAT-Cup Premium a much better program with the different options that it has for objective function, multi-objective function, behavioral objective function, and so on. There is a lot of things really that you can do there, and much better analysis and calibration. So I will not be doing much with SWAT-Cup 2019. So I encourage you to switch or to use SWAT-Cup Premium after this. All right, thank you for your attention. And if there are any questions, please write me an email and we'll try to answer it. Bye for now.